Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Fortran programming. Now, in the last few tutorials we were looking at successive factorials, how to use do loops, nested do loops, labels, and some cautions you have to consider while doing loops and all. And how naming the loops with certain with labels gives makes it mandatory that we have to end the loops with label names and all. Now in this tutorial I'll be telling you and in this tutorial I'll be moving to a new concept, and this is nothing related to the program part of it, but this is more related to the execution part of the executing the program. Okay, now I'll explain you guys how to compile this entire program, compile, build and execute the program in from the terminal. Now what you guys can do is that you can go to the folder where this program is stored, or open a terminal and go there. Okay, where regardless, go to the place where the file is and open the terminal with the directory with the place on, and then and then you can use a terminal to run it. Okay, now I don't have to do that here because in Genie there's this inbuilt terminal which is exactly the same as the terminal that you have outside, so it doesn't matter. So all you have to do is that go to this, instead of opening separately I can go to this and run them directly here, and that's one of the advantages of Genie. Okay, now my program is in home, Arun, Fortran Tutorials and Factorial. Now this tilde symbol indicates that it's home, Arun, and then I'm in the same for tutorial folder as that as the file is. So if I just list all the files with the command ls, it's a shell command, but doesn't matter for now. Okay, I get a lot of files like these. Now this is the program I wanted to look at, but there are some green files which I haven't heard of, and there's this text file and this .o file and all. We look at that one by one. What I do, I don't want these. I just remove all these files, not all of it. This and this and this and this and this. If you guys want to know what I exactly did, double click the file name with your left mouse key and then move it to the place where your cursor is blinking, and press the scroll wheel or the middle mouse button, and it'll automatically print. It's like very easy to do copy, and this works in Ubuntu and maybe in some other Linux versions, but I'm not sure whether this will work in other versions or like Mac and all, but it's worth a try. Then what you do is just click enter, and what I see is that all these files are removed because we need this. Now to get the results, it's a 3-step procedure for Fortran. First, what you have to do is that we have to compile it. To compile this file, what you have to do is type gfortran, okay, and then the file name, with the compiler flag -c, okay, and then type the file name. It's do_factorial and click enter. Looks like nothing happened, but if I just click ls, if you guys see, I get a file called as do_factorial.o. It's exactly the same file as this, but with a .o extension, and this file is called as an object file. This file gets created whenever a compiler program. This kind of files get created whenever a compiler program gets compiled and all. Okay, now these object files are important because these object files help us to build the executables. Now to make an executable out of this, what you have to do is that you have to type gfortran again and then type o file, this time o flag, -o flag. What this o flag does is that it collects all the object files that we mentioned here, merges them to produce one executable. And when we do that, what you do is just type do in factorial, and you have to give that .o file and click enter. Yeah, let's see, it says that it won't do anything because we need to specify a file name for this. What I do is I just specify a file name called as fact. Okay, now this is a little annoying. I think I made it a little wrong. I think this o flag has to come here. Okay, o flag has to come here. So this way you're writing the Fortran name. I'm using actually the compiler invoke you're invoking the compiler here using the object files, okay, and minus o flag for building, and this fact will be executable. If I click enter, it looks like nothing happened, it didn't show any error or warning. If I just click ls, I get this green color file called as fact. Now this fact is actually an executable. It may not have an extension, but this is an executable file, and that all the executable files are indicated with a green color here. So what I do is that I just to execute this, I just type dot and a backslash symbol, and then type the fact word, and then click enter. And just like what you saw in the terminal, this becomes an inbuilt terminal, and all I have to do is that type the word, give the input, and it works fine, just like what we did. And the best thing is, after doing all the execution, the file gets closed, the file gets closed, and the execution stops, and then it reverts back to the previous process the shell was actually working on. Okay, now this is actually a three-step process, wherein first initially you compile the file with this keyword. Okay, let me just clear this up. So this is actually a three-step process. First you have to do is that you have to compile the file with this statement, and build the file with this statement, and then run it with this statement. Okay, now there's another simple way to do it. What you can do is that g fortran, okay, and type do factorial.f95, okay, the file name alone. If I click enter, nothing happens, but if you just press ls, you get this file called as a.out. Now what I did is that this operation compiles the file and builds executable in a single step. Why I'm not using this is because this will give a default name of the executable as a.out, and if I just type run this a.out with this notation in Ubuntu and Linux, it will work the same. If you just press 10, and it works the same, and it closes. And there's this another way also. Okay, this time what do you do is that this is the second way of compiling and building, and there's this third way wherein you write the name of the file and click and type -o, and then type the executable name like fact.fact1.exe, something like that. If you click enter, nothing shows up, but if I click ls, you get a new executable called as fact1.exe. Okay, this way you are creating an executable instead of the default name a.out, and if you want to run this, it's the same, fact1.exe, and it works the same. That's it. And there is this one more feature here which I want to tell you guys here. What you can do is that click once these are done, okay, there is this option I want to tell you guys about. See, if you guys notice, I told you that if you guys include this preprocessor directive, you can make the this not only makes the compiler to by default use this one. I told you that you can make the file as an executable that can run on its own without generating any executable files and all, right? I'll explain you guys how that works. What you do is that you can convert this executable file into this file into a non-executable. Okay, if you just press ls, if you guys notice, these files, the fact1.exe and a.out are executables, whereas these two are not executables. But you can make these executables and run like how fact1.exe and a.out got run by this command. And this is actually a shell command. What you can do is that you can write something like chmod 755 or chmod 777, whichever you go. I prefer the chmod 777. This has something to do with file permissions for read, write, and save and all, modify and all. If I were to write this, if you guys have a little doubt in that, you can check Google about it. There'll be I'm sure there are a lot of people explain about file permissions and all. Okay, write chmod 777 and then type do_factorial.f95. Click enter. What happens is that this becomes a green color value. Now it becomes green. Now let me see if this works. If I just type do factorial, it may not work. Oh, it may not work. Let's see if I were to if I were to type g Fortran and then type if I were to type g Fortran and then type 2 factorial dot f95, it works fine, but something's not right. A dot oet 10, fine. Now I'm pretty sure there is I think there is something to work with. I think I'm not doing it properly, I suppose. Okay, I'll let you guys know how to execute them in just a single line, and if there is any, I'll let you guys know. If there isn't, I'll let you guys know that there isn't any. I haven't tried this before, so I don't have any idea about this. I thought of giving it a try. Okay, anyway, let's clear this up. And there's this one more way also. Suppose if you want to store all the answers, suppose if you were to execute a file and if you want to store all the output that you get on the screen except the values that you feed on, okay, there's this option. While you do this executable file, press this greater than symbol and point it towards a text file like this, fact.txt or sometimes fact.dat, whichever. Direct it to an executable like this, and what it shows is that it doesn't show any output because all the output will be transferred to the text file. It won't show anything here, unless it will show only those values that be turned out to be a warning or an error only here, and all the proper and all the proper outputs in the log file will be in the fact file. So it's still waiting, but the program is not quitting, it's still running, it's just waiting for me to give the value. If I just give 10, it closes, but it doesn't show any results. But if I want to see what happens, it creates a new file called as fact.txt. Okay, now if I were to open this up in Genie, okay, if you guys want to open this in terminal, just type Genie and the file name, and that's it. Click enter, and there you have it. The whatever result you put, it gets printed over here. Instead of printing it over here, it gets typed over here. As simple as that. And this is the way of recording a lot of inputs and all. The only thing is it didn't press 10 because 10 is dynamically sent as input, whereas these values get printed as per the function, as per how the code worked out. Okay, so that's the only difference. Well, that's all I have for you guys in this tutorial. In the subsequent videos onwards, we will not be using the build and compile features. We'll be using the compile and build features only to check for any debugging errors and only for debugging and all. But while we'll be compiling all the files and running them through from the terminal from here onwards. And this is the reason why I did not prefer using code blocks, because code blocks is really good, but I haven't found a way to do this process over there. But if you guys find it, do let me know. I learn instead. I learn and correct this up. Okay, that's all I have for you guys in this tutorial. See you guys next time. And by the way, I forgot to mention you guys all the programs that you're doing here in these tutorials, and all the programs I did in the previous tutorial, which I am slowly deleting in the videos because those videos are too long. I'm deleting those videos. All the two programs that I did over there and over here are actually available for public access. If you guys check out the description of each and every one of my video, I'll be giving a link towards a Dropbox folder, and in that Dropbox folder I have a folder called as Fortran Tutorials, and inside all the programs that we did so far are uploaded over there. You guys can have a look at it, and do check the folder every now and then, because whenever I make any file, I'll just upload them over there, so you guys can have a look. That folder is has public access, but you cannot go there and modify the content, but you are allowed to view. You're allowed to just view and get the files out. And that's all I have for you guys in this tutorial. Thank you guys for watching, and see you guys in the next tutorial. Bye.